So this will be the second lecture out of chapter 19. So in this lecture, we'll look at the reactions that make amines, so how to synthesize amines. So there's one simple way, and that you can take an amine with an alkyl halide and do an SN2 reaction, for example. So lone pair of nitrogen can attack carbon and kick an iodine off to give you this, and then you can lose a hydrogen. So the electrons in the NH bond become a lone pair. And so now you've synthesized a primary amine. But the problem with the synthesis is that now this nitrogen has even more electron density on nitrogen because alkyl groups are electron donating, right? So that increases the electron density on nitrogen. So that means this nitrogen is an even better nucleophile. So as soon as you make it, then it could react again. So take a lone pair of nitrogen and do another SN2. And then lose a lone pair on nitrogen, or lose a hydrogen on nitrogen. And so now you would have a lone pair on nitrogen, so now you have a secondary amine. And that's an even better nucleophile because now you have even more electron density on nitrogen. So this could react again. So you can take a lone pair, make another bond to carbon and kick another iodine off, and then lose a hydrogen, and now you have a tertiary amine, and that's still a nucleophile because it's still got a lone pair of electrons on nitrogen. So it could react with a fourth equivalent of the alkyl iodide. And now you have the quaternary amine, and now there's nothing it could do. So the point is, this is not a very good way to synthesize amines because you get a mixture of all four. You get some primary amine, you get some secondary amine, you get some tertiary amine, and you get some quaternary amine. So you would have to do a purification at that point if you try to synthesis like this. I mean, you could try to control the stoichiometry and use one of these and one of these to just make the primary amine, so 1-to-1 ratio, but you would still get some secondary, tertiary, and quaternary amine. So we'll go through some other ways to synthesize amines that are much better. But if I gave you a problem like this on the test, then I would expect you to sketch all four possible products: primary, secondary, tertiary, quaternary amine. Okay, so if you just wanted to synthesize a primary amine, then one way to do that in very high yields is to do what's called Gabriel synthesis. So this molecule, which you can buy, is called phthalimide, and that hydrogen is fairly acidic. So if you react it with a strong base, you can take that hydrogen off. So something like tert-butoxide, oxygen will take that hydrogen. Right, nitrogen has one lone pair to begin with, and now it's going to have two because the NH electrons will become a lone pair. So this is fairly stable. Negative charge because its resonance delocalized through both carbon-oxygen double bonds. But this is also, so this is called potassium phthalimide. You could buy that as well. That's commercially available. And it's also a very good nucleophile, so you can use it to do SN2 reactions. So you can take a lone pair on nitrogen, make a bond to carbon, and kick off a leaving group. And that would give you this. And now if you wanted to free up the amine, well, you just have to find a way to cleave that out of the compound, and there's a variety of ways to do that. So once you have that, then you can do an acid hydrolysis, or you can do a base hydrolysis, or you can react it with hydrazine. Would be three of the more conventional ways. So if you took this and reacted it with water, so basically we won't go through the mechanism here. We'll cover this type of a mechanism in chapter 21, I think it is. So basically water can go there and kick and break that bond, or the water molecule could attack here and break that bond, and now, so the water will lose the hydrogen and nitrogen will pick a hydrogen up, so then you would have the amine. Although technically this is reaction that's done in acid, so the amine would react with that acid to make the ammonium salt. So if you wanted the free amine out after you did this reaction, then you would have to do a third reaction where you'd have to neutralize the acid by throwing in a base Hydroxide would take that hydrogen back off to make water, and then you would have the amine. Right, or you could use hydroxide for this. So you could do a base hydrolysis. Same basic concept. Hydroxide would react here and break this bond, and a hydroxide could react here and break that bond, and out comes the amine. And you would get carboxylic acid side product, but since it's in base, then that carboxylic acid would be deprotonated. And the only difference being here is that your side product is the conjugate base of a carboxylic acid rather than the dicarboxylic acid that you would do if you had acid hydrolysis. Right, or you could react this with hydrazine. And so basically what happens is similar. So one nitrogen reacts here and opens that up, and the other nitrogen reacts here and opens that up. Then each of these nitrogens lose one hydrogen, so they end up as NHs, and the nitrogen ends up picking those two hydrogens up, and you get your amine out. And so then you make this side product, which is basically very insoluble. So it would typically precipitate out, and you would just filter that off to give your amine. Okay, so the point is, you take phthalimide, you deprotonate it, and then you take that and react it with something with a good leaving group on it. And so this nitrogen attacks there, kicks the leaving group off, and then you just have to have a way to cleave the amine out. And these are the three: acid, base, hydrolysis, acid hydrolysis, base hydrolysis, or react it with hydrazine. So of course we're mainly interested in the amine that comes out. So it's easy to predict the products of these reactions. You just have to recognize, right, that nitrogen is basically going to end up attached here, and you're going to kick whatever the leaving group is off. So your product would be that, right? So this nitrogen basically ends up as an NH2 wherever the leaving group was. So same concept here. That nitrogen is going to end up attached here, and that chlorine is going to be gone. And you would have the primary amine. Okay, so we've seen this reaction of amines before. So if you take an amine with an epoxide, then if you remember, it's base catalyzed, so the amine goes to the least substituted carbon of the epoxide and opens that epoxide. And then nitrogen loses the hydrogen, and the alcohol picks that hydrogen up. And you would make that as the product. Okay, so several other ways to make amines. So if you react it with azide, if you remember what azide is, it's just a very good nucleophile. It can attack and kick a leaving group off. And then azides are susceptible to reduction. So if you take an azide with hydrogen and palladium, that will reduce the N2 to NH2. Or you could use lithium aluminum hydride, and that'll reduce the azide, the N3 to an NH2. So nitro groups, you can reduce nitro groups as well. So you know how to put a nitro group on a benzene ring, HNO3. H2SO4, and then once you have the nitro on the ring, you can reduce it to NH2 with H2 and palladium, or lithium or aluminum hydride. A variety of reducing agents will do that. But those would be the couple that I expect you to know. Nitriles. If you make a nitrile, so CN's a good nucleophile, right? That will do an SN2, so that's back to organic 1. But once you have a nitrile, then it can be reduced. So the triple bond, you can reduce that to a single bond. So H2 and palladium, we'll add H and H across the triple bond to make a single bond, a double bond, and then add H and H again, and now you have a single bond, and now you have a primary amine. So each of these azides make primary amines, reducing a nitro, makes a primary amine, reducing a nitrile, right, makes a primary amine. So it is possible to make secondary and tertiary amines as well. So this is a reaction we'll look at in more detail in chapter 21. But if you take an acid chloride with an amine, then this will lose HCl, and then nitrogen will end up in its place. So you would make that amide, and then once you have an amide, you can reduce it. So since we started from ammonia, that would make a primary amine, or if we started from a secondary amine, if we started from a primary amine. So again, if we lose HCl and attach nitrogen to the carbon-oxygen double bond, then when you reduce it with lithium aluminum hydride, now you have a secondary amine. Or if you started with a tertiary amine, so again, lose HCl, and just attach nitrogen where the Cl was at. And then if you reduce that, so when you reduce amides, you just reduce the C double bond O to a CH2. Right? So let's contrast that to how ester is reduced. If you remember how ester is reduced, so if you remember how ester is reduced, that bond gets cleaved, and you end up with two alcohols. Right, but that's not what happens with amides. You don't cleave that bond. The nitrogen remains attached to the carbon chain. You just reduce the C double bond O down to a CH2. Okay, so if you had that amide and you reduced it with lithium aluminum hydride, then you would make that amine, right? Because all you do for amides, is reduce the C double bond O down to a CH2. Okay, so one more reaction of amines, one more reaction that produces amines, and then we'll look at in the next lecture some reactions that amines undergo. Okay, so this reaction, it's actually a sequence of reactions in here, is what's called reductive amination. So there's two things going on here. So if you remember what happens here, if you take an aldehyde or a ketone and an amine and acid, then that would make the imine. And now once you have a carbon-nitrogen double bond, just like carbon-oxygen double bonds and carbon-carbon double bonds, they will reduce with H2 and palladium. So you would just add H and H across the double bond, and you would make the amine, in this case, a primary amine. So similar here. So you have an amine, ketone, and acid, and that's a primary amine, so it should make an imine. Right, so that's a reaction out of the aldehyde chapter. Right, just take that nitrogen and double bond it where the carbon-oxygen double bond was, So now you have an imine, and that will react with H2 and palladium. So you do all of this in the same flask, you just mix it all together. So as soon as you make the imine, then it reduces to the amine. So now you just add H and H right across the double bond. And you would make that secondary amine in this case because you started with a primary amine. And if it's a secondary amine that you start with in a ketone, then if you remember, this is your recipe to make an enamine. And then once you had the enamine, it would react with H2 and palladium to add hydrogen and hydrogen across the C double bond C. And you would end up with that tertiary amine. Okay, so that's the reactions of amines that you have to know.